Hi again! This is the fifth part of the series where I describe the whole process of creating a space shooter in Godot 4. Before we dive into the collision detection system, which is the main topic of this video, let me remind you that you can get the whole source code of the game on GitHub. The link should be included in the video description. As mentioned in the previous video, the player's ship is represented by the class Character Body 3D. This class was specifically designed to handle user control objects and includes several methods for managing collisions with other objects. Currently, we utilized the move and slide function to ensure smooth movement within the boundaries on the screen. Additionally, we could make use of another function called move and collide with the parameter velocity to handle all interactions with enemies. However, our game doesn't follow the typical slide collide platformer concept. It takes place in space without the presence of gravity, narrow passages, sliding doors, and similar elements. Consequently, we need to address these unique characteristics. Moreover, I would like to have greater control over the collision system because there can be different scenarios when enemy objects interact with the player's ship or the bullets or anything else. To implement this plan, we took the following steps. We will get rid of this line first. And now we already have collision shape 3D, which is bound to the player's object. Let's do a simple trick and add a new child node to the player's root node, and this one would be area 3D. And let's duplicate this collision shape 3D. Ctrl C, click Ctrl V, and it is here, and it should be of the same shape as the original collision shape 3D. Why did we do that? The point is that area 3D implements signals like area entered, area exited, and so on, which are not implemented by Character Body 3D. So this will allow us to detect collisions programmatically in an easier way and handle them accordingly. So let's get prepared for that. We click the area 3D again to open an inspector, and in the node tab we can see the area entered signal. So let's double click it and confirm the window, and a new function on area 3D area entered has been generated in the player GD script. We will again replace the default body with a simple debug message, print area. Later, of course, we will handle the collision properly here and do all other actions like destroying the object, calculating the collision, and so on. Okay, so we want to use Godot's collision detection system, but we aim to establish selective collision interactions because we don't want everything to collide with everything else. For example, we want to prevent the player from passing through the boundary, but we want the enemy ships allow them to do so. Moreover, we don't want enemies to collide with each other, but they should definitely interact with shots and missiles and anything else that the player's ship can fire. And to accomplish these specific requirements, we will leverage collision layers and masks. Let me show you a list of layers I prepared because it's important to plan ahead and make sure that it would have space for every object types we want to include in our game. First layer, player's ship. This includes everything in the player's object and the area 3D that contains the collision shape as well. Second, enemies, like asteroids, ships, anything that can collide with the player, hence the layer 1. Third, player's bullets, including phasers, missiles, and everything else that can be fired from the player's ship and should interact with the layer 2. 4, enemy bullets, like all shots that are aimed onto the player and can interact with the layer 1. Boundaries. I think this is clear. We created these static walls and only the player's ship can interact with them. 6. Power-ups. Specific object that will be dropped by some enemies and can be picked up by a player's ship to give it some more powers, specific features like more firepower or similar things. 7, 8 and 9 are reserved for future objects. And last one, debris. This is basically an array of objects that would be created from a destroyed enemy, because if the enemy is modular, like the player's ship, not exactly enemy, but the principle is the same, it would create debris objects out of body, wings, engine, etc., and this object would just drift away. By the way, if you don't want to remember these numbers, there is a way to give names to the layers. It can be done here in project settings, general, and layer names should be somewhere down here. Yeah, layer names, 3D physics, and this is exactly where we would name our layers if we want to. So first we will go through each scene individually and set their layers in inspector collision layer. Let's start with the character body 3D, the player's object. Click back to inspector, and here we have the collision menu, and yeah, we will assign the mask 5 because the player wants to interact with the boundaries. Now, the collision area 3D, this one, we will keep the layer 1, and as for the mask, we want to assign 2, 4, and 6, because as we know, 2 are enemies, 4 enemy bullets, and 6 power-ups. All these objects should collide with the player's object, and we should handle interaction right here in this method. And the last one, the player's ship will have a shield, which is not implemented yet, but once we do that, it should have the same mask except 6, because the shield won't interact with power-ups. Okay, now enemies. We already have an enemy object, which is asteroid, so let's click it. Let's find its collision collision section, and we know that enemies should belong to layer 2, and they should have the mask 3 because we want to shoot them down with the player's bullets that belong to the layer 3. Okay, we don't have anything else, maybe just boundaries, so we get back to main. No, it's here, boundary. Yeah, here it is, left wall, collision. Yes, we can give it the layer 5, and the same to all other walls. Layer 5, and the mask is 1 because it will interact only with the layer 1, which is the player's ship. Top wall, again layer 5, and the bottom wall in layer 5. Okay. To ensure that the new functionality is working correctly, we will execute the game and verify that the asteroids still interact with the player's ship, resulting in the message being displayed on the game console. So let's do it, and let's navigate to some asteroid. Okay, and if we close the game, yeah, we can see that the debug message is here, area 3D, which I think points to one of the asteroids, which should be visible here in the enemy GD. Yeah, this is exactly the part that caused this message to appear in the console. To make the game more playable, it's important to introduce a sense of vulnerability to the player, because simply making the player invincible and immune to everything would be no fun. We can begin by implementing the most essential event, when the player's ship's collides with any enemy object, it will be immediately destroyed. As we continue developing the game, we can enhance this functionality by incorporating additional features, such as calculating hull integrity and shield power. But for now, let's do this very fundamental function. So, when the player's ship is destroyed, the event occurs within the player ship's scene, which is this one. But the handling of the destruction, which involves a sequence of actions such as destroying the ship's object, ending and restarting the game level, and applying various audiovisual effects, it needs to take place in the main scene. To establish communication between these layers, we can utilize signals. Signals are an important feature used for inter-object communication and event handling. Signals allow objects to send messages or emit signals, which other objects can listen to and respond accordingly. In our code, we already are utilizing signals. For example, I think we have here the signal, area entered. Now, we will extend the usage of signals by defining a custom signal called player destroyed. Let's do it in the code. So open player GD and add signal definition here. Signal player destroyed. Okay. And now we want to send a signal in this method where the player's ship collided with an enemy object. So instead of printing debug message, we will do this. Player destroyed, emit. Okay, the signal was sent. Now we need to catch it somewhere and handle. This will be done in the main GD script. So first, let's implement the method called on player destroyed. Okay, and in this method we will destroy the player's objects safely. Player Q free. Okay, now we need to call this method when the signal is received. So we need to connect the player object to this method and to the signal. It will be done here in the ready function. So player connect, and now name of the signal player destroyed and the reference to the function, which is done like this: callable self, as the function is included in the same object, and name of the method. Let's copy paste it on player destroyed. Okay, good job. Now we can check it out. Let's start the game and let's collide with asteroid, and the ship is gone, and the ship's data are gone from the debug overlay as well, because there is nothing to display. So we have a fully functional collision system, and it's time to enable the player to engage in combat by firing bullets to destroy enemies and obstacles. Fortunately, we can utilize the knowledge and techniques we have already acquired from previous videos to implement this feature seamlessly. So let's switch to Blender and we'll create a simple bullet object here. Okay, let's select everything and X to delete to have a blank scene. Now we will add a cylinder. Shift A, mesh cylinder, and now we need to rotate it down. So I press 3 at the numpad to get this view, R to rotate, Control and move the mouse. Okay, here it is. And now we need to scale it down and make it longer. So S and move the mouse, this one, S and Y to extend it on the Y-axis. Very well. Now we need to add a tip of the bullet. So we'll rotate the camera a little bit, press Tab to edit. Now face select here, select this face, E to extrude, click, and now S to scale and 0 to make it just a single point, and click. Okay, it looks like a pencil, but it still will be a fully functional bullet to shoot down the enemies. Let's export it as the GLTF like before. Now we don't need to do anything here because we didn't apply any modifiers. Simply let's call it bullet GLD and export. There we go. Let's get back to Godot and import this new model into our project. It would be here, so let's find the exported file, there it is, and drag it to the models folder. And we have a new model here. We'll do the usual stuff, right click, new inherited scene, and ready, yeah, here it is. And we will change the type to area 3D. Change type, area 3D, and it's necessary to add a collision shape, of course. Child node collision shape 3D, and this time we'll give it a cylindrical shape, yeah, cylinder shape 3D, and we need to rotate it to match the bullet. Let's do it here. Rotation. Is that X? Well, we'll see. 90, yeah, perfect. And probably we should make it a bit longer. Let's try 3, too long. 2.5, okay. And move it a little bit. Yeah, that should be fine for collisions. Great, let's save the scene as bullet TSCN, save. Now we need to attach a script to this new scene. So click the root node and click this icon to attach a script, bullet GD. And let's implement the basic functionality. We will need the process function. We don't need the ready function. Okay, let's start. Current direction. Because later we will implement homing missiles, so the direction can change over time. Right now it will be static, just from the bottom to the top. And we need two variables to specify the power and other features of the bullet. First of them would be hit points, so we know how many hit points we should subtract from the enemy if they are hit by this bullet. The default value would be 10. And the second variable, export var speed, and the bullet should be a lot faster than other objects. We will set the speed to 150. Okay. And again, since we added these variables with the export annotation, we should be able to modify them later here in the inspector. Okay, now let's implement the usual init function. Init. Yeah, because we want to know in some cases a ship would have more than one weapon, so we want to know exactly where the bullet should start its trajectory. This is the node weapon. So position is at the weapon position. In fact, the weapon's nozzle. We will mark this object later on the 3D editor. Global position. And to be sure that there is nothing outside the usual x-axis plane, let's set the y coordinates to 0. Okay, and now we need direction, node, get children. Okay, let me explain this. The weapon objects will be defined with a so-called direction node, which simply specifies in which direction the bullet should be shot. And there will be always only one direction, which is why it's safe to expect that there will be only one child of the weapon node, so we can get the first index of this array, and always it will always work without errors. Okay, now current direction would be set here, equals direction node position. Okay, and now, as I mentioned before, some bullets would be homing missiles, or maybe they won't be shot in the bottom top direction, so we need to calculate the direction angle. Direction angle. Vector 2 this time, because we are still in the XZ plane only. Current direction X. Current direction Z. And now we need to calculate the angle between this vector and angle 2 and the top vector, vector 2 up. Okay, and finally, once we have this angle, we can rotate the bullet object to follow the right direction. Rotate Y and direction angle. Okay, and finally the process function. In the process function, we will move the bullet with the preset speed, so it would be vector 3 with parameters 0, 0, negative delta by speed, because in the default implementation will be moving upwards. And okay, we need to get rid of the objects once it leaves the game area, because in many times we won't hit anything and the bullet would just go up and up forever. So if game manager not is in boundary, self Q3. Yeah, by the way, the exclamation mark, it's just a habit from other programming languages. Godot documentation recommends to use a more descriptive not, or and or and this kind of words. Okay. And as usual, we need to monitor the number of bullet objects in the debug overlay. So let's start with adding this scene to the proper group. Signal groups, and let's call it bullet. Bullet. Okay. Now we'll switch to the debug overlay scene and modify the script. Var bullet count is 0. Let's copy and paste this line and change it bullet count and bullet. Okay, and here new line bullets, bullet count, and end of line. Okay, of course nothing would be displayed yet because the bullets are not added to the scene yet. Let's fix it. Open the player's ship scene, and now we will add a new node, weapons. It would be node 3D. Let's rename it to weapons, and we will add the first weapon, another child node of node 3D type. Let's call it main, and we need to give it the only child, as we mentioned in the in the blood script, and this child would be direction. Again, node 3D, and we'll call it direction. And now we need to properly position these nodes. So let's open the 3D editor, click Y to get a top view, and let's move this main node here to the nozzle, and direction should be a little bit upwards. Okay. Okay, and let's create the side weapons as well. We didn't explicitly model any physical cannons here, but let's suppose that these edges are the side cannons. So we'll click the main node and click Ctrl D to duplicate. Let's call it left and move it. Okay, this and here. Okay, and once again Ctrl D, right, and we'll move it there. Actually, we can do it in a more clever way, because we will open transform and see this coordinate X. We will just change negative to positive. Good. And the direction is always in the right direction, of course. Okay, now we need to distinguish between active and inactive weapons, because at the game start only the main phaser would be active, until of course we pick up some power up to activate the other weapons. So let's add a new script to this node main, and we'll call it weapon. Okay, and we will add this same script to left and right as well. So weapon, load, and right weapon. Okay, and this will be a very simple script. We don't need any functions. We will only specify one variable, active false, which means the weapon is not active. And we will then specifically in the script set the active variable to true to the main weapon only. So let's do it now. Open the script player's player GD, and we will just add a new variable here. Let's drag weapons and hold Control, so it creates this declaration automatically. Now we'll create a new variable weapons, which would be an empty array at this moment. And what's the problem? Of course, the name collision. Very well, let's call it weapons node. Okay, and let's create the functional init. For weapon in weapons node get children, so which will simply give us an array of main, left and right. If weapon name is main, weapon active is true, and let's add it to the array weapons append weapon. Very well. And of course we need to call this method from the main script. But before we do that, there is one more thing. We need another key mapping for the shooting action. Let's open project settings, input map, and we will add shoot primary weapon, because later we will introduce a missile, a homing missile that would be fired by another action. And let's map it to a left mouse click. Click. Okay. Close. Let's proceed with implementing the fire cadence in the script main.gd. What does it mean? Our objective is to introduce an auto-fire functionality that allows players to continuously fire bullets by merely holding down the mouse button instead of requiring them to click for each individual bullet to be launched. However, to ensure a balanced gameplay experience, it becomes necessary to define a specific interval between each shot. So let's add some variables first. Var fire cadence is 0.2, which equals to 5 bullets per second, and var fire cooldown is 0. This will be necessary to calculate the intervals precisely. And yeah, I already added player init line here because we need to call the function we just created a while before to activate the weapons, and we also need to pass the player object to the game manager because it will be required there for some functions, especially the firing. Set player. Yeah, this function doesn't exist there yet, but we will shortly add it. Okay, now in the process function we need to detect whether the player pressed the button to shoot. So if input is action pressed, shoot primary, and fire cooldown is less or equal than 0, let's call the function fire bullet. It's not there yet, we will just add it. And let's recalculate the fire cooldown to make sure that the function fire bullet is not called more often than it should. Delta. Very well. Let's add the mentioned function fire bullet, and again we need to make sure that the player's ship is active, otherwise there is nothing to fire. So is valid node fire cooldown. What's the matter? I forgot to indent the line. Oh, there is a semicolon instead of colon. Okay, now it's correct. Fire cadence, and we will call another function that doesn't exist yet. Fire player weapon self. Again, a reference to the root node. Okay, let's implement what is not there yet. So we will open the game manager script, and first we need to add a new variable player and the function to set it up. Set player and player is underscore player, and before we can fire anything we need to add the bullet scene here. Let's find it. There it is. Again, drag and click hold Control and add the annotation and the variable declaration on ready var bullet scene. Okay, good. And finally we'll be firing. Let's move it here. Okay, func fire player weapon root node reference. Okay, for weapon in player weapons, let's iterate through all weapons and find out which are active to fire them. If weapon is active, let's instantiate the scene and add it as a child node to the root node. Var bullet is bullet scene instantiate bullet init weapon and finally root node add child bullet. Okay, I wanted to make a new line. Let's run the game and press the left mouse button. Okay, it's firing, but the cadence is not working. I must have forgotten something as usual. Let me find it. Yeah, of course, the auto-completion betrayed me this time. There shouldn't be this action just pressed, which captures just one click, but is action pressed. So it will be called even if the mouse button is just pressed and no more clicks are created. Let's try it now. And I will just hold the left mouse button. Yeah, it's firing correctly. There are no collisions yet, of course. I mean, they are collisions, but they are not handled. We will do it in the next part. However, there is an important component that we have yet to include. We need to implement an audio feature that produces the iconic pew 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 sound whenever the ship's weapon is fired. To achieve this, let's explore the audio system provided by Godot. So we will start with adding another autoload script. This time we will create a whole scene. So let's right click, create a new scene, and we will call it Sound Manager. Sound Manager, and okay, there it is. We will attach a new script, Sound Manager GD, and as usual we need to add it to the project settings. Here in autoload, let's find a new scene and add Sound Manager node name. Okay, now we need to download a shooting sound. A very good resource of a lot of free sounds is freesound.org. I visit it very frequently and usually find everything I need there. And in fact, I already downloaded a suitable sound. Let's create a new folder, sounds, and select it. There it is, and I will drag the bullet sound there. And here we have it. Now, in our new scene, we need to create a child node of the type audio stream player. We will rename it to bullet sound, and in the inspector we will drag this WAV file to the stream property. Okay, perfect. Now what we need to do is to implement the function in the script, the function that would actually play this sound. So we will remove everything that's not necessary here and control drag this node here. So we have a reference to the bullet sound, and create func fire bullet and simply bullet sound play. That's it. At this moment nothing else is required. Let's save it, and we will call this function from game manager. So here, each time the weapon is fired, we need to play the sound, and we'll play it only once because we don't want to have three sounds at the same time in case of all weapons being activated. So sound manager, fire, bullet. Okay, let's test the game again. Can you hear it? Perfect. By the way, there was a small bug with the sound. You might have noticed that. I'll show it again. Let's play the game. If I just click the mouse and release it, it's still playing over and over, which is not correct. The reason is that the sounds are sometimes imported with an active loop, which we don't want to. So we will click the bullet valve here and go to the scene panel and switch to import. And what we need to do is to find loop mode and switch from detect from WAV to disabled and re-import. Now if we run the game again, it's correct. No repetition again. So yeah, keep it in mind if you encounter this problem. This is the way to fix it easily. Although we can shoot currently, nothing occurs when a bullet collides with an asteroid. Let's address this issue and implement the necessary fixes. So we start with opening the asteroid scene here and make sure that the signal on area entered is here and connected. Yeah, looks correct. Let's go to this function and implement a new code. If area is in a group, because we want to handle it only when it collides with player's bullet. Let's call the lifecycle script within the function process hit. I think it's not there yet, we'll shortly implement it. And remove the bullet, as there is no point to handle it anymore once it hits its target. There we go. And now we will open the lifecycle and add the method in question, func enemy. Found process hit, of course. Enemy area. And before we do that, it seems that we don't have any hit points there, so it's not clear if the enemy is fully destroyed or it can still be alive until we shoot it again. Very well, let's add the missing code here. First we need a signal to signalize the main script that the enemy was fully destroyed. Signal enemy destroyed, and this time we'll use a parameter with the signal because we will want to display some kind of fire and we need to know exactly where it happened. Source node. Okay, now var max hit points, the initial value, which we will set later. Actually it will be set from the spawn configuration. And hit points, the actual value, which would be decreased after every hit. Now in the init function we need to add the hit points, to set them up. Is spawn hit points, and max hit points is set to the same value and at the time of initializing this node. And finally, let's connect the signal. Connect enemy destroyed to again callable root node, because we will implement the function that catches the signal in the main script, and it will be called on enemy destroyed. Very well. And now we can proceed with the function process hit. So hit points will be decreased by the bullet's hit points, and if hit points drop below 0 or equal to 0, the enemy is destroyed and it should explode. Yeah, a new function which is not there yet. Let's add it. Func explode enemy, and we'll simply send signal enemy destroyed with this parameter. Okay, and of course we added this new property 8 points to spawn structure, so we must use it in the enemy definition as well. Let's amend the spawn variable in game manager. Spawn asteroids, there it is. We will add it to the start. Hit points, and let's set it to 20. So it would take 2 shots to destroy an asteroid, because if I'm not mistaken, the bullet hit points are 10. Yeah, right. Okay, and we will implement the function on enemy destroyed. Let me just copy the name and switch to main GD, and here func on enemy destroyed with a parameter enemy, and we will simply for now destroy this object. Later we will improve this function body with more actions, but let's just test this basic functionality. Okay, let's start the game and test it. Nothing is happening. We have to omit something. Let's check. Yeah, I know. It seems we forgot to add the correct layer and mask to the newly created bullet object. So let's open it, collision here, and as we know it is the layer 3 and it should interact with layer 5, the enemies. Let's try it again. Yeah, 2 bullets and asteroid is destroyed. 1, 2. Perfect. Number of enemies 1. We destroyed 4 of them. Great. In the next video we will improve this now underwhelming disappearance of asteroid when destroyed by introducing a spectacular fiery explosion.